This problem is from the University of Arkansas math competition, and this is the tiebreaker round number 1. So let's take a look at it. There's a line through the origin that divides the region bounded by the parabola y equals x minus x squared and the x-axis into two regions with equal area. What is the slope of that line? Well, as always, let's start with drawing a diagram. That's going to be my y-axis, and that's going to be my x-axis. And so we got the bounded by the x-axis part, but we need to find out how to draw the y equals x minus x squared. So let's find the roots. And to find the roots, we always set it equal to 0. And you can see that you can factor out the x here actually to x times 1 minus x equals 0, which means the roots of x are 0 and 1. So if you draw this parabola, you get something like this, and then it goes down, and then it goes down. Okay, so the neat version of this parabola would be something like that. That's the x minus x squared, that's the y equals mx with some unknown slope that intersects the parabola, and that is the a is the intersection, the x value of the intersection. Okay, so where should we start? Well, since all we're given in this problem is about area, we should probably find the total area of the region. And that's going to be using calculus. As we know, this parabola goes from 0 to 1 in the positive x and y axis. So, to find the area of the region bounded by this parabola and this x-axis, we find the integral 0 to 1 of x minus x squared dx, don't forget the dx, equals, well, as you know in calculus class, x squared over 2 minus x cubed over 3 as 0, x goes to 0 to 1. Okay. And this, of course, equals 1/2 minus 1/3 minus 0 minus 0 equals 1/6. Okay. So we just found that the total area of the parabola is 1/6, and I'm just going to put that information on the side here. So the area of the parabola equals 1/6. Okay, now what else? Well, we haven't used the information that this line divides a parabola into two areas of equal area. Two areas with equal area, yeah. So we need to use this information, two regions with equal area somehow. And well, to do that, let's take the integral of, I don't know, find this area first, because that's going to be 1/2 of the total area, which is 1/12. So to find the area of this section, just this section, we can do the integration of 0 to a of the top function, x minus x squared, minus the bottom function, y equals mx, so just mx. And again, we're doing this because we need to use the information that this line divides the y equals x minus x squared into two regions with equal area. So this gives us x squared over 2, x cubed minus x cubed over 3, minus mx squared over 2 as x ranges from 0 to a. And this, of course, equals a squared over 2 minus a cubed over 3 minus ma squared over 2. And this, and what does this equal? Well, this equals the half of the total area because we're only looking at this part, right? So that is, since we know that the total area of the parabola is 1/6, that must equal half of that, which is 1/12. So let's clean this board up a little bit. And I'm going to put this equation up there because we're going to have to use it later. Okay, so here's an interesting thing, right? We're looking for the slope of the line which intersects a parabola, which is m. We're trying to find m. Here we have two variables and one equation. If we can somehow relate a to m, we can solve it for m because that would be one equation, one solution. one variable. So how do we relate m to a? Well, interesting, right? How do we relate, since we're talking about y equals mx, how do we relate one function to another expression? We look at the intersection at this point. And at there we can see y equals ma and y equals a minus a squared, because we are plugging in the x value of a into both functions at the intersection. And because it's the intersection, we can equate these two. ma equals a minus a squared. Now solving for this equation, we get ma minus a plus a squared equals 0, and a times m minus 1 plus a equals 0. Since a is between 0 and 1, that can't be 0. So m has to equal m minus 1 plus a has to equal 0. That means m equals 1 minus a. Okay, and that's going to be a key. Because that, if we juxtapose that one to this equation, we get two variables and two equations. So we can solve for it. So let's do that. Plugging in for, let's look at this equation, the a squared over 2 minus a cubed over 3 minus ma squared over 2, and we're going to plug in for m. Okay, so a squared over 2 minus a cubed over 3 minus 1 minus a times a squared over 2, that 2 looks weird, equals 112. Okay, let's rearrange this a bit. A squared over 2 minus cubed over 3 minus, well, what's this? A squared minus a cubed over 2, right? And this turns into a squared over 2 minus a cubed over, 3 minus a squared over 2 plus a cubed over 2. So that's convenient. These two cancel out, and what we get is a cubed over 2 minus a cubed over 3, which is a cubed over 6. So that's interesting. We get the equation that this expression, is a cubed over 6, which equals 12. And that means a cubed equals 1/2, and a equals cube root of 1/2. And then it becomes really easy from there. We just plug a into this. And since m is what we're solving for, we're done. M equals 1 minus a equals 1 minus cube root of 1/2, which is the answer. Alright, thank you very much.